Snowball error. What is it and how to avoid it? So what is snowball error? Well, the best way to learn about it is to first encounter it, and then we will discuss. So we'll do an example. We'll calculate a table of sine and cosine values. 1 theta, 2 theta, all the way up to 60 theta. We'll compute it for 3 different values of theta, pi over 180 and then 1/60 of that and 1/360 thousandth of that. So we calculate pi over 180 in that one, and then we will multiply it by 2 or 3, etc., and bring that down. And then in rows 1 and in 60, we will use the exact values because we were given those. But we'll have to use our formulas to calculate the numbers in between. So how do we calculate the numbers in between? Well, the simplest way is to just add theta to the number above. So this is the sine alpha, cosine beta, sine beta, cosine alpha formula, where beta will be theta. So, similarly, this is a cosine alpha, cosine beta minus sine alpha, sine beta. But the beta will be theta, 1 theta, and we're going to put the dollar signs there, so it's always 1 theta that we're adding each time. And it computes numbers. They're reasonably good numbers. But let's look at the percentage error associated with this calculation. We're going to calculate 60 in 2 different ways. We're going to look at 59. We'll bring that down, and then we'll add theta to it. That should be 60. And then we'll compare it to the exact formula for 60. And the percentage error will tell us how accurate our calculation is. 2 times e to the minus 15. Now machine epsilon is 1 times 10 to the minus 16. So this is 20 machine epsilon, which is not a disaster, but not real good either. We could do better. We can probably reduce it to less than 1/10 machine epsilon if we employ some technique. Let's look at the other calculations and see if they have the similar issue. So we just copy over what we did, but change the angle. Okay, 4 machine epsilon in this calculation. That's not bad, but 32 machine epsilon? That is not good. We can do better. So let's discuss what snowball error is. Snowball error is the issue of cumulative error caused by doing multiple calculations on calculations. Each calculation causes a small computation error. Doing calculations on calculations cause these errors to snowball. in the same way that a snowball rolling down a snow-covered mountain grows. So in example 1, we saw the snowball error was 20 epsilon, machine epsilon. Yeah, this is what's happening when you're doing your calculation. They're just growing, causing a disaster. So these are sequential calculations. And each calculation is causing a bigger and bigger snowball error. That's because each error is the sum of all the errors prior. So how do we deal with the snowball error problem? There are two basic ways, and we can do both. We don't have to choose one or the other. Reduce the error of each calculation. An example is array summation. And then bypassing calculations, reducing the number of calculations to get to your number. So the example is the highway byway method, which we'll talk about a little bit later. But the idea is you do calculations in parallel. Okay, array summation. We're going to add up 15 numbers, and then we're going to sum up each row, 5 numbers there, get a subtotal, and then sum up those subtotals to get a final number. Does that do anything? You wouldn't think so, but it actually does. I'll do an example and you can see how this array summation could help. This is kind of a silly calculation, but it illustrates the issue. We're just going to sum up the same number, the square root of 2, a bunch of times and see how much cumulative error we get by summing it up. So we're going to do a running total. So that's going to be 2 of the square root of 2. And then the E column will simply use multiply the numbers to avoid any round off error. It'll just do one calculation each row. And the point we will do is we'll compare the running total with the exact solution to see how much error, percentage error, we're generating. So let's look at the D total, which is the running sum, to the E, which is the multiplying method. And we get 988 machine epsilon. That is absolutely terrible. Almost 1,000 machine epsilon. We lost 3 digits. Now I'm going to use Excel's sum function to see if that does anything different. No, it doesn't. It's exactly like the running total. It calculates sums by just adding the previous number. It's exactly the same. So now I'm going to skip over some of this, but just show you how to do an array calculation. So over to the far right, there's these logics. And what it's doing is it's counting 10 and then saying, okay, that's my number. 10, 20, 30, 45, 50, up to 100, up to, and beyond. And then the column to the right, it counts 100 each time. 100, 200, 300. Column to the right of that, it counts 1,000 every time. We'll have to hunt for 1,000. Okay, there's 1,000. And so what these numbers to the right do is tell Excel that, okay, if I encounter one of these 10s, I sum the previous 10 numbers. But that's it. I'm only adding 10 numbers to each other. I'm not adding more than that. I want to add small numbers to small numbers, not small numbers to big numbers. That's what's causing the error. And then if I encounter 100, the hundreds, I sum up the 100 numbers to the left of that. It's only 10 non-zero numbers. I'm adding slightly bigger numbers to each other. And then the same logic goes to the next column to the right of that. In that column, there's only 10 numbers that are non-zero. We can add those together. That's the L column. And that should be all the numbers. So let's add up the L column. Does it make a difference doing it this complicated, convoluted way? Well, I wouldn't show it to you if it didn't make a difference, but how much difference does it make? You'd be surprised. Yeah, one machine epsilon. It eliminated the problem essentially completely. Okay, the highway byway, we're going to compute the highway, which are nodes that we can compute quickly to skip all the side calculations. Then we'll do the byway to get to a particular number. So an example, if we want to do 33, skip to 30, and then add 1, 31, 32, 33. So exercise 2 will use the highway byway method to do this calculation. So we're going to repeat the calculation we did before, but we're going to do it better. We're going to use these identities. The half-angle formulas, the double-angle formulas, we can use them to skip quickly to the middle of the calculation. Those are the highways. So we'll use the sine alpha, cosine beta, etc. formula and the cosine alpha, cosine beta, etc. formula. But we're going to use m theta and k theta. M theta, m is a highway. So here the highways are 30, 15, 8, 4, and 2. Those are the numbers we can calculate right away, skipping all the byways. So let's go to the spreadsheet and see how this new method works. And we're not going to repeat everything. We're just going to start with what we did, but we're going to make a few changes. So we're going to highlight the first column, and first row, and the 60th row because those were given. And then we're going to do the highways. We're going to highlight those in yellow to indicate that we're going to skip everything else and do those calculations first. So what's the formula? Okay. For 30, we're going to use the formula square root of 0.5 times 1 plus cosine 60. Likewise, for 15, we'll do square root of 1/2 times 1 plus cosine of 30. Okay, for the sine, we do sine of 60 divided by 2 times cosine of 30. Likewise, for 15, we do sine of 30 divided by 2 times cosine of 15. Now we go the opposite way. Here we're going to double. 1 minus 2 sine squared. We're going to do the same thing. 1 minus 2 sine squared. Whoops, I got to put the equal sign in there. Okay, yeah, that'll fix the problem. 1 minus 2 sine squared. In this case, it's sine of 4 theta squared. And then we'll do the 2 sine theta cosine theta formula. And that way we can double 2 sine theta cosine theta, double 2 sine theta cosine theta. Okay, now we'll do the by-way calculations, but here we're going to fix the number in the corresponding to 4 theta, because that's our highway. That's in row 6. So we're going to fix row 6 corresponding to 4, and we're going to add 4 plus 1, 4 plus 2, 4 plus 3. Then for the 8, 9, we're going to fix the row corresponding to the 8, because 8 is a highway number. And we're going to put the dollar signs on that. And do the calculation. It's 8 plus 1, 8 plus 2, 8 plus 3, etc. Now we're going to fix the row corresponding to 15. That's in row number 17. We're going to put the dollar signs on the 17. And then finally we're going to fix the 30, which is in row 32. We'll put the dollar signs on row 32. Bring it down. So we're doing 30 plus 31, plus 1, 30 plus 2, etc. Okay, look at the error there. 2 times machine epsilon. We'll see it again a little bit later. We're going to copy this calculation to the right. We're going to change the angles to see what those numbers are for the smaller angles. How much error we get. Go through this calculation quickly. Okay, here's the errors. Either 2, 1, or 2 times machine epsilon. That's pretty much perfect. So time to close the spreadsheet. Thank you.